Okay. Báwo pé ó jẹ́ ènìyàn lè rìn? Mo fẹ́ kọ́ wò bí ó ṣe rí nínú ilé. Wọ́n fi service system yẹn náà ṣe.
Ó dàbí bí ó ṣe rí náà ni.
Ṣé ẹ kéèyàn lè rí lè báyìí? Tẹ bá wò ó ní. Àgbà mi ni màá fi sínú rẹ̀. Good day to you, co-learners. I want to discuss with you common substances, which are acids, bases, and salts. I call them common substances because we do make use of the names in our everyday activities. An acid is defined as a substance that ionizes in water to give hydrogen ions as the only positive ions in solution. Okay, but acids have been taken. This class is for bases and alkalis, but I need to mention acids to get them together. What are bases? If I was asked this question when I was younger, I would have defined bases as substances that kill, because a playmate, a childhood playmate, was a victim of a base, the one used in making soap. That is caustic soda, sodium hydroxide. But as a chemistry student or as a chemistry scholar, because I'm still learning, I will define a base as a substance that ionizes in water to give hydroxyl or hydroxide ions as the only positive ions in solution. These bases, when you see them represented as chemical formulas. How will you be able to identify them? When a metal combines with oxygen, formed is called metallic oxide. Now, when this metallic oxide dissolves in water, we have metallic hydroxides. Both, I mean metallic oxides and hydroxides, are bases. Please get it with me. Oxides and hydroxides of metals are bases. They are. And as you can see in this illustration, you can see sodium oxide, which is formed by a reaction between sodium metal and oxygen. And you can see its corresponding hydroxide. So also you can see potassium oxide and its corresponding hydroxides, and all other hydroxides and their oxides are seen in the cardboard. Now, this bases, we have some of them that are water soluble, while some other ones are practically insoluble in water. Those ones that dissolve in water are called alkalis. Alkalis. Now, you can permit me to say all alkalis are bases, but not all bases are alkalis. Only soluble bases are alkalis. Alkalis are basic hydroxides that dissolve in water. That is what they are. These alkalis can be divided into strong and weak ones. What is that thing that makes us call some strong alkalis? It is their degree of ionization in water that makes us say that. Now, any alkali that dissolves completely in water, fully in water, is a strong alkali, because we are going to have numerous hydroxide ions, which are the markers of bases. Why any base that dissolves partially, that dissolves, it dissolves reluctantly in water, leading to less hydroxide ions. That is a weak alkali. And as you can see on the cardboard, you can see the weak and the strong alkalis indicated. Potassium and sodium hydroxides are strong alkalis because they undergo complete ionization in water. Why aqueous ammonia, that is ammonia to which water is attached, and the other one, calcium hydroxide, that is lime water. The two are weak alkalis because they undergo partial ionization in water. You can see potassium hydroxide ionized to give potassium ion and hydroxide ion. That is full ionization, complete ionization. The hydroxide is reasonably ionized in water, while for the other one, calcium hydroxide, it is only partial ionization, which produces few hydroxide ions. You can now distinguish between strong and weak alkalis like this. Now, the next one is what are the properties of these alkalis? You are familiar with properties of acids, that acids have sour taste. Acids, they change blue litmus paper to red. Acid in their concentrated form of strong acids are corrosive. Now let's move to bases. Bases, they have, soapy texture. What I'm trying to say is that they are soapy to touch. Also, the alkalis, they are bitter when tasted, and like the acids, the concentrated form of strong alkalis are corrosive. The one used in the manufacture of soap is called caustic alkali, dangerous alkali, because it can cause destruction to living things. Now, these are the physical properties of alkalis. And of course, you should not forget, alkalis, they turn red litmus paper blue as against the acids that turn blue litmus paper red. These are the physical properties of alkalis. Okay, by definition, let me move to alkalis again. Alkalis, like potassium hydroxide that we can see, it ionizes to give potassium ion and hydroxide ion. Don't forget, this is a marker of alkalis, hydroxide ion. That is why alkalis were previously defined together with other bases that they are substances that react with acids to give salts and water only as products. What do we mean by this? We know hydrogen ions are generated from acids, and like I said, hydroxide ions are generated from alkalis. The two, when reacted together, we give water. That is neutralization reaction, meaning that I'm good to define a base as a substance which neutralizes the effects of an acid to give salt and water only as the product. Now, this definition of neutralization will now make me modify the definition of an acid, because an acid, when in aqueous solution, produces oxonium ions as positive ions. You know, acids cannot just ionize by themselves, just like that spontaneously. They need to be in water, that is aqueous medium. And in aqueous medium, oxonium ions are generated and not hydrogen ions. This one will now make me to define neutralization in two different ways: as a reaction between hydrogen and hydroxide ions to give water. And don't forget, a salt is also formed in the process. Also, neutralization is a reaction between hydrogen ions and oxonium ions generated as a result of ionization of acids in water to give salt and water as the product. And the definition of an acid as a substance that gives oxonium ion in solution was given by Arrhenius. Okay, back to my alkalis. We've known strong and weak alkalis by their ionization in water. These alkalis, and they are together with hydrogen ions in neutralization. Okay, we've seen the physical properties of alkalis. What are the chemical properties? Of course, neutralization is one. The hydroxide ions from alkalis associate with hydrogen ions from acid to give water. And always put it at the back of your mind that a salt is formed in the process. This can be illustrated with this with the first equation on this cardboard, in which copper 2 oxide reacts with H2SO4 to give us copper copper sulfate, a salt. Also, water is formed in the process. This is one chemical reaction or property of alkalis. Another chemical property of alkalis is that they react with ammonium salt to liberate ammonia gas in the process. And this their reaction requires heat to take place, meaning that heat is needed for the reaction, and it is indicated by the sign under the arrow, that delta. That one indicates heat is needed for the reaction to take place. These bases that are implicated to be dangerous agents or chemical substances, what are their beneficial uses? One, sodium hydroxide. We know it is used in the manufacture of soap. Soap. Also, potassium hydroxide also is used in the manufacture of soap, but liquid soap for potassium hydroxide. Another base is aqueous ammonia, which is some anions and cations in the lab. Aqueous ammonia, a very important agent, which is also used as a bleaching agent.